Okay, so the rational function is a functional that is a fraction. So you learned rationals in grade 11 a little bit. So when you talk about a fraction in math, what do we always worry about? What's the big idea with fractions that can't exist? We've talked about it 100 times. Last year, this year already. You can't do what with a fraction? You can't divide by 0. Okay, so that's a big thing in this unit. Okay, so a non-permissible value is a value that's not allowed to exist because it creates that error. So tell me in this first example, what is the non-permitted value for x? What is x not allowed to be because it makes that problem 2? Okay, I'm going to make you think about grade 10, grade 11. You are professionals at this, factoring. Right? You're professionals. I can't teach you again. You have to have all this down pat. What are your styles of factoring again? Give me something. GCF? There's 4 of them. Difference of squares. Simple trinomials, complex trinomials. Okay, so this I can factor. What is the style I would call this one? I can GCF. There's a 2 I can pull out, which makes a x minus 5. So what x value am I not allowed to be at now? I can't be at 5. 2 times 5 is 10. 10 minus 10 makes that 0. Okay, I'm going to skip this one and do this last, actually. Okay, which style of factoring is this one called? It's one of them. Difference of squares. So 2 brackets, xx. How do you do a difference of squares? Plus minus 3. So on this one, I'm actually not allowed to be 2 different values. There's 2 bad values. So x negative 3, x positive 3, those are the non-permitted values. Okay. Also this one of the styles, so it's a simple trinomial. So what do you do with simple? You say what is the multiplier at the end, adder in the middle. So 2 numbers that multiply to 14, 7 and 2. Need to make a minus 5 out of it. Okay, so two non-permissible values on that one as well. Okay, this one I left to the end. It's a little bit tricky. This is not factorable. Okay, it's not a difference of squares. Some people might look at it and said, oh, that's a difference of squares. It's not a difference of squares because it's not a subtraction sign. Okay, so I'm trying to get this to be 0. So this is my idea. This is what you're always technically doing. You're trying to think about this bottom being 0. What do I know? So how would you work this through algebra? You would subtract 1 and square root. What do you know? You can't do that. So there's none. There's no values that create a problem. Okay? Do you understand when you square something, it's either going to be 0 squared, 0, or any number squared makes positive besides 0. So either 0 or positive plus 1 is going to always be positive. So you're not creating a 0 ever. Okay, so here's the deal. when you have a non-permissible value, like that, it creates a vertical asymptote at 2. Unless, there's this other special case, unless so here the non-permissible value is 2, but if there's ever a situation where it gets canceled, it's going to create a hole in the graph instead of an asymptote. So this one happens to be a line, and it will have a hole in it instead. Okay, so we're going to do some more work with that, but that's the rule. Non-permitted values are vertical asymptotes unless there's been a cancellation, and then it'll just create a hole in the graph instead. Okay, so now we're going to go into the horizontal stuff. So that's us worrying about x values. So now we're going to worry about y stuff. So horizontal stuff. Before we go into the horizontal stuff, do you understand what a degree is? So when I look at this equation, the degree of this equation is actually that it's a cubic equation, because that's the highest thing I found. So this has a degree of 3 because of that being the highest exponent, and the leading coefficient is 2. So you always have to look at the biggest thing, and then that's the degree, and that's the leading coefficient. Okay, usually I write it, it's written first, but if it's not, you have to identify it. Okay, so here's what happens. In this situation, this is degree 2 on the top. It's an x squared, so it has a degree of 2. And on the bottom, this has a degree of 1 because it's just an x to a 1 exponent. So you're higher on the top. So if your number on the top gets bigger than the bottom, you are just going to get bigger. Does that make sense? If the number on the top of the fraction is getting bigger, your number is getting bigger. So then, no restrictions. Okay, so now we have degree. This has a degree of 1 because it just has an x in it. And this has a degree of 1 as well. So this means that the degrees are the same. So what should I do if the degrees are the same? I'm going to divide. Obviously those would cancel. Every time if they're the same, they're going to cancel, dividing just the leading things. And I end up with getting a 2. And what does that mean? It means there's going to be a horizontal asymptote at 2. And then the other situation you could have, so this is a degree of 1 and this is a degree of 2. So there's 3 situations, right? We could be higher on the top, the same, or higher on the bottom. So this is higher on the bottom. So what happens in math if the number on the bottom gets bigger on your fraction? So I'm just going to give you like a visual here. If I did something like 1 over 10, 1 over 100, 1 over 1,000, what's happening to the number if you get bigger, bigger, bigger on the bottom? What's going on with the number? It's getting smaller and smaller and smaller. So what is it getting closer to as a value? Closer to 0. So you're just going to get your height, your value is going to get closer and closer to 0. So you're going to have an asymptote at 0. There you go. Now you're pros. You know everything there is to know. That's it about rationals. That's how you graph them. Okay, so you got the rules. Non-permitted values for x. They're either vertical asymptotes or canceled makes wholes. If there's a higher degree on the top, you don't worry. If they're the same, you divide. If they're higher on the bottom, 0. All right, we're going to graph some. Okay, first example. You ready? I need you to factor what you can. That's your step 1. So I'm going to factor this bottom. I'm going to use simple trinomial methods, 5 times 3. Okay, so here's what I'm going to do. I'm going to tell you there's non-permitted values for x. I don't want x to be a -5. I also don't want x to be a -3. Okay, so now this cancels. So because that was a cancel, this creates a whole. This one didn't cancel, so that means there's going to be a vertical asymptote. Now, let's talk about the degrees. Before I crossed it off, this was a degree of 1. And then this was a degree of 2. So it is higher on the bottom. So what do you know about that? What was the rule? Y equals 0 is the horizontal asymptote. Okay, so you have this, this, this. These are the 3 big things. Okay. Now, after we cancel, if we were to cancel that, what does your equation look like? Y equals, if that got stroked out, what should I write on the top if I canceled something? 1 over x plus 3. Okay, so here we go. I know this. There's a horizontal asymptote at 0. There's a vertical asymptote at -3. And there's a hole at -5, comma. What's the coordinate of the hole? So what am I doing? I'm going to plug a -5 into this. So what do you get? What's -5 plus 3? Negative 2. What's 1 divided by negative 2? Negative a half. Okay, so here's what we're going to do. We're going to draw these things. So I need you to draw me a vertical asymptote and a horizontal asymptote. Okay, so there's my 3 important things. And then I have to make a few more points so I can figure out how to draw it. So here's what I'm going to do. I'm going to pick a couple x values. So what's a good number to pick? Probably this negative 2, negative 1, so that I can get a couple on that side of it, and I'm going to do a couple on this side. So I'm going to go with negative 2 and negative 1. I'm going to plug them in. Okay, so here I go. I'm plugging them into this. What do you get there? So what's negative 2 plus 3? 1. What's 1 divided by 1? 1. I'm going to plug in a negative 1. So negative 1 plus 3 is 2. 1 divided by 2. So I got 2 coordinates, and I can tell my shape already. Because what does an asymptote behavior do? You always do what with asymptotes? You get closer and closer and closer and closer to them. Okay, so now I'm also going to pick negative 4 and negative 5, but we've already done that. So I picked 2 on that side of it, and I'm going to pick 2 on this side of it. So when I plug the negative 4 in, I get negative 1. And we already did our hole, so now can you see the shape from those 2 coordinates? There we go. So I have to see your hole in the graph. Make sure you draw it as an open circle like that. Okay, I don't know how many I want to do. Let's go jump one. Let's try this one. Okay, so I'm going to go with what is the non-permissible value situation? What is x not allowed to be because of that divide by 0? 1. Would that be considered a vertical asymptote or just a hole in the graph? Vertical asymptote. So there's an important piece of info. That's it. There's no holes. There was nothing that went cancel, cancel. So that's not in here. Let's go with the degree situation. What's the degree on the top? If it's just an x, degree 1. Just a degree 1. So they are the same. So what should we do when you have the same degrees? You should divide those liters. I don't care about this other thing. I'm only dividing the liters. If they're the same liters, I'm going to divide them and get a horizontal asymptote. Okay, so we are done the analyzing part. That was that first page when I said you know all you need to know. This is it. So there's a vertical, there's a horizontal, there's no holes. So I'm going to draw these things.
It didn't. Oh, yeah. East Field.
Okay, so analyze, get all your important stuff. Now we need just a few points to make shapes. So what kind of x values do I pick to plug in? So if this asymptote is at 1, I'm going to probably be picking a 2 and a 3. So I'm going to pick a 2 to plug in and a 3 to plug in. So 5 times 2 divided by 2 minus 1. Plugging in a 2. So this is going to be 10 divided by 1, which is 10. All right, plugging in a 3. If I plug in a 3, I'm going to get 15 divided by 2, which is 7.5. Okay, can you plot those 2 points and see if you can make a shape out of it? So 2, 10. And then because you have your asymptotes to guide you, can you see what it's going to do? It's going to go closer to that asymptote, and it's going to move closer to that asymptote. Okay, so here's my asymptote. We made the shape on the right-hand side of it. Now we need to make the shape on its left side. So what kind of x values would you grab? So remember that this is at a 1. So we did 2, 3 on that side of it. So I want to do, are you going to pick 0 and -1? Would that make sense? I'm going to pick 0 and -1. So I just did 2 on the right side of it and 2 on the left side of it. So 5 times 0, that'll just be 0. And then -1 plugged in. Everybody know what that is without a calculator? Without a calculator, Tyson. 2.5.
Oh, I guess that.
It's just that
Yeah, remember you don't have a calculator on this kinds of stuff on your exam.
easy.